So we're now going to take a look at the client structure and functionality. And as I'm describing you how this works, I'm also going to talk about another way to implement things, and we'll kind of talk about the pros and cons of each approach. So now we're focusing on the left-hand side of this diagram, where we're making clients that are going to make asynchronous get and post requests to the server. So we have a class called the PCClient class, and there's two of them. We have one for parallel fluxes and another for the concurrent approaches. And we do this so we can do different implementations on the client side. And these classes perform asynchronous remote method invocations on the controller to determine the primality of large integers. So let's take a look and see how this works. So we've got a component, so it could be auto-wired together. It's got a proxy, and this proxy, of course, is what these methods are going to use to actually make asynchronous remote invocation calls on the server. And it's all auto-wired together using Spring's dependency injection framework. And then we have two different methods, one called test individual calls, and you can see it takes a flux of integers, and the other one's called test flux call. We'll take a look at test individual calls first. So here's what test individual calls does. You can see it uses a ParallelFlux to make all the calls in parallel. So what it's going to do, as you can see, is it's going to do all the parallelism on the client side, and it's going to do this by converting the flux to a ParallelFlux, running on this bounded elastic scheduler we're about to talk about. And then the map method is going to end up calling the checkIfPrime method for each of the prime candidates, telling it to use a ParallelFlux to do the actual computation. And we do this up until the point we're done, and then we turn everything back to a sequential flux. We use the bounded elastic scheduler because these calls are going to go over the network, and we want to make sure that we don't block. This just performs the remote method invocation via proxy, and that'll dispatch to the checkIfPrime method. Here's what the test flux call method does. It's going to send a flux of integer objects to the server with a single HTTP post request. So let's take a look at this. It's super duper simple on the client side. All we do is we take that flux of integers, which are the prime candidates, and we forward to the server using the proxy checkIfPrime flux method, passing in the prime candidates and saying we want to use parallel fluxes to do this. That's the strategy we use. In this model, the parallelism is performed by the server rather than the client, whereas before, in this model, the client provided the parallelism and the server just did each thing one at a time. It'll probably come as no great surprise that the checkIfPrime flux implementation works a lot faster because we're only doing a single remote method invocation rather than making each call its own remote method invocation. Let's take a look at the proxy. This is implemented using the Spring 6 or beyond, Spring 7, whatever, interface client feature. So this is the HTTP interface feature that's available in Spring 6 and beyond, which will declaratively abstract away low-level details of remote method invocations. And this, of course, is very important for doing the next programming assignment 2C, that's due on Friday, because you have to write these proxies yourself. So this is an interface. We define two methods, checkIfPrime and checkIfPrime flux. These shield the client from details of low-level programming. We put the appropriate annotation to generate either HTTP GET or HTTP POST requests. This very similar to GET mapping, POST mapping. It's just called GET exchange, POST exchange. We put in the path variables that'll route the GET and POST requests to the appropriate endpoint handlers. And then we also, in this case, will indicate that we want to pass the parameter. We're passing a flux as a parameter. So this is what you have to do if you're defining something that will pass a flux. You have to put in this tag. This is application ND-JSON value, and then we can pass a flux as a request body. The values you have here, request param and request body, those are really the same annotations that you would see either implicitly or explicitly on the server side. By the way, good tip, this is a good place to use ChatGPT. The latest version of ChatGPT understands the way in which the Spring HTTP interface feature works if you prompt it correctly, and it can generate these proxies for you automatically. So that's a good thing to keep in the back of your mind. This proxy method, check if PrimeFlux, returns a flux that will emit these integer object results. So that's really cool. So that's the walkthrough of how the client is going to be designed. And next, we'll take a look at the client implementation.